Hello, and today's purpose of the day is I can apply translations and dilations to a quadratic function. The main idea for today of transformations of quadratics is looking at graphs and seeing how they can be changed. So if we look at the top left graph, we notice that the green graph translating to the blue graph is a translation of going down 4 units. If we notice the second middle graph, we see that the blue graph and the red graph are different in that they reflect over the x-axis or they can reflect over the y-axis. The third graph with the green and the red parabolas is that if we start with the green parabola, we notice that we can translate up 3 units to get to the red graph. Down in the bottom left, the red and the blue graph, we see that if the blue graph is our original and the red graph is the new parabola, that we're going to get wider, which is called a compress. And then the last graph, if we start with the blue graph and get to the green graph, we are translating up 2 units, and we are also having a thinner graph, which is called a stretch. And all of these different transformations are what we are going to be talking about in the next few slides. Okay, some new vocabulary. A transformation changes the position or size of a figure. A translation moves a figure up, down, left, or right. However, the general shape of the graph is unchanged. A dilation makes the graph narrower or wider, and a word that we are going to use to reference narrower is called a stretch. Wider is called a compress. And a reflection flips a figure across a line. Okay, let's look at our first example, vertical translations. If we look at the key concept there, we are looking at the green graph as our beginning graph. So if we notice with the red graph that we are translating up a certain amount of units, and with the blue graph we are translating down a certain amount of units, and all of that depends upon whether or not we have plus or minus a number in our equation. Let's look at the few examples we have here to get a little bit of a better idea. Describe how the graph of each function is related to the parent graph of f of x equals x squared. So if I look at number 1, h of x equals x squared plus 3, and number 2, g of x equals x squared minus 4, h of x and g of x, again, are just different notations of how to write f of x, but there's a big idea here with, on the first one, with this plus 3, and a big idea on the second one with this minus 4. That is a translation, a type of vertical translation that is happening to this graph. So what do you think the answers are to numbers 1 and 2? You guessed it. So for A, h of x equals x squared plus 3, or number 1, what is happening there is that graph is actually translating up 3 units from the original parent function of f of x equals x squared. So here, if the green one is the parent function, okay, green, right there, draw an arrow, that is just the basic graph of f of x equals x squared. Now the red is up 3 units if you count along the y-axis, 1, 2, 3, and that's why that translation there is x squared plus 3 up 3 units. For part B, this minus 4 here that's happening to the blue graph just means I'm translating down 4 units from the original parent graph at, at 0, 0 for the origin, down 4 units. Example 2, dilations. So a dilation means that the graph is going to either stretch or compress vertically. Again, stretched is another key word for if that parabola is getting, I like to call thinner, and compressed is there's a word to use for what I like to call getting wider. So if we have, and we know that we have dilations if there's a certain number in front of x squared. If a, and here's this first key concept here, if a, and again a is the number in front of x squared, is greater than 1, that absolute value. Okay, if the absolute value of a is greater than 1, the graph will stretch vertically, which means our parabola will become thinner. So this is again in red. Now on the other hand, if a, the absolute value of a is between 0 and 1, so what I like to say a lot of times is a fraction, a decimal. But you got to be careful because that fraction could be over 1, but many times when we have fractions, they're typically between 0 and 1, which we'll see for this unit. The graph of f of x equals x squared is compressed vertically, which means it's going to look like the blue here and look a little bit wider than the original parent graph. So let's take a look at the two examples and describe how the graph of each function is related to the graph of f of x equals x squared. Number 1 is h of x equals 1/2 x squared, and number 2 is g of x equals 3x squared plus 2. What do you think they will do? And you guessed it again. You are 2 for 2. All right, so on part A, describe how the graph of each function is related to f of x equals x squared. This 1/2 x squared is going to be compressed vertically because it's getting a little bit wider. So again, key concept here was that A, the 1/2, is between 0 and 1, the absolute value of it, so it's going to be compressed. Part B here, if we look at part B, the 3 right there means my parabola is going to stretch, okay, and then that plus 2 means translate up 2 units. So that would be the answer for that one, stretches and up 2 units. And again, that up 2 units was because of the plus 2. All right, example 3, reflections. So we can have two types of reflections, over the x-axis and over the y-axis. So the graph of, and this is the one we'll commonly see the most, of negative f of x is the reflection of the graph of f of x equals x squared across the x-axis. So if I have a negative in front of A, that's going to be an x-axis reflection. But the graph of f of negative x is the reflection of the graph of f of x equals x squared across the y-axis. And again, we don't talk about the second one as much. We talk about the first one quite a bit more because that's what we see more with quadratics, at least for right now. So example 3, this is just one that we'll talk about briefly. It's not in your notes, but describe how the graph of g of x equals negative 2x squared minus 3 is related to the graph of f of x equals x squared. So g of x equals negative 2x squared minus 3, and we need to relate that to the graph of f of x equals x squared. So there's 3 transformations that are happening here. The first is the negative sign that's in front of the negative 2x squared. The negative here is going to have a reflection across the x-axis. So if you notice on the parent graph in blue, here it opens upward, but now with our translations that are occurring, it's going to open downward, and again, that's because of the negative, and we know about that from before, that if a is less than 0, our parabola opens downward, and here it is, it's negative 2. Then the 2 causes a dilation, and 2 is greater than 1, the absolute value, I should say, of negative 2 is 2, which is greater than 1, so that's a stretch. And if you can see, I crossed out, the book had a wrong answer there, so that's a stretch. And then the minus 3 means that this parabola is translated down 3 units. So if we look here, all of those are occurring down 3 units. It's a bit thinner, right, stretched, and it's opening downward, which is a reflection over the x-axis. So those are 3 things that are happening there. Now I would like you to look at 3a and 3b and describe how the graph of each function is related to the graph of f of x equals x squared. So 3a is h of x equals 2 times negative x, the quantity squared, minus 9. And 3b is g of x equals negative 1/5 x squared plus 3. Good luck. Nice job. You are 3 for 3. Well, the answer again to 3a, which you had correct, was a stretch, reflection over the y-axis, and down 9 units. 3b was a compress, reflect over the x-axis, and up 3 units. Once again, great job. And here are a few more examples to add to your notes, so please take a few minutes to describe the transformations from the parent graph of f of x equals x squared. All right, let's look at part A. H of x equals negative 3x squared plus 1. The negative in front means that we have a reflection over the x-axis, so reflects over x-axis. Again, we're going to see a lot more reflections over the x-axis, and we will necessarily talk about the y-axis right now. The 3 means that we stretch, have a stretch, and then the plus 1 means up 1 unit. All right, let's look at part B. F of x equals negative x squared plus 8. Again, the negative in front means we have a reflection reflects over x-axis. There is no coefficient in front of the x squared, so it's a negative. That just means we have a reflection, so the 1 just means that we're similar to the parent function. There is no stretch or compress. Then the plus 8 is up 8 units. All right, last but not least, part C, g of x equals negative 1/5 x squared minus 2. So again, the negative means we reflect over x-axis. The 1/5 is between 0 and 1, so that's a compress, getting wider. And then the negative 2 is down 2 units. Thanks for listening. Great job. Please check Google Classroom for your assignment today. Good work.